Pygame. About me, I've been programming for about 6 years, given the lightning talks in Australia. I've recently made an app called Tiltworm, which you can buy at Google Play, or just by scanning this. I've been in a couple of Pi Weeks, which is just a game programming challenge. And if you need, you can contact me at kmousetheawesome@gmail.com, and after maybe in a couple of days, I'll have this up where you can download everything and a bit more. So I've got a couple of games here. This one's the most recent. I made it for the last Pi Week. It's quite simple, you just jump to move. It's got some animations and stuff, but I made the entire game in just 1 week for Pi Week, and so it wasn't actually too hard after I started. So on to Pygame. So you can download Pygame from pygame.org and just download the one for your version of Python. I'll be using Python 2.7 for mine. I'll be looking at the screen, drawing, the Rect type, event handling, time, images, sprites, and if I have the time, I'll look at sound as well. So to start Pygame, you just start by doing import pygame, and then to initialize the module you do pygame.init, and then that will create your first pygame, which closes really quickly. So now that you have it closing quickly, you can create the display surface. This is the surface that everything gets drawn on. It's the screen that the user sees. So to create the display surface, you go screen, which you don't have to call it screen, but that's just a name that makes it completely unambiguous. So you go screen equals pygame.display.setMode. And then you can set the resolution, which is the width and the height, any flags, which is just some settings that Pygame has, and the pixel depth, which is in 32 is a good level because it supports alpha and just looks nice. So let's make it 640 by 480. Set mode. 0 if you just want nothing, and 32. You can leave these two out. They're not really necessary, but they help a bit. And so now it opens up the display surface before closing. So here's some of the flags you can use. You can do pygame.fullscreen to make it full screen, double buffers the screen, hardware accelerated in full screen, an OpenGL renderable display, resizable will allow the screen to be resizable, but you need to be a bit careful with that. No frame will just get rid of the border. You also need to be careful with that because when the close button's gone, it's kind of hard to close your program. And SRC alpha gives you an alpha channel which you can draw on. So the display surface is just a Pygame surface, which you can create by setting something to pygame.surface and then setting the width and the height and the flags and the depth. This isn't drawn automatically, but it's useful in some cases. I've also just underlined all the variables just to make some stuff easier later on. So you can do commands on surface, including the display surface. You can do surface.blit and then surface location. This will draw this surface on this surface at this location. surface.fill will fill the entire surface or the area you set to be this color, which is in RGB, and if you have SRC alpha, you can also do an alpha channel and all 255, and surface.getRect will allow you to get the rectangle area of your surface. I just want to say, you might not understand everything I'm saying at first, because Pygame's something you just like grab bits from everywhere and you put it together, so I will explain everything by the end, hopefully. So here's an example of a surface program that I made. I've got two surfaces, the orange surface, which is the display surface, and the blue, which is just an ordinary surface that I made. I'm also drawing some shapes on it, which I'll tell you how to do soon. And so anything that's on this blue surface gets cut off by the edge, and anything that's on the orange surface gets drawn over by the blue surface. So I'm drawing a blue circle on the orange surface and an orange circle on the blue surface. So then when you get to the edge, the orange one gets cut off and you can see the blue surface. So here's why you need to be careful with resizable. If you have a resizable screen, the surface of it doesn't automatically get resized as well, so you'll need to change that whenever you resize it. So pygame.display allows you to modify things in a surface. So you can do pygame.display.setMode. Pygame.display.update will allow you to do things like screen.fill. So by default, nothing gets drawn automatically, or it gets drawn onto the surface, but then the display surface doesn't automatically get drawn onto the screen. And so then you can set that to be like 255, 155, 55, and then you do pygame.display.update to draw it on. And so I don't have anything to stop my program finishing, so it'll just draw it orange and then just close. And so pygame.display.info will give you some stuff about the actual screen resolution of your computer and some other stuff. Pygame.display.flip will flip the surfaces or something when you're using double buffering. So drawing shapes. To draw a shape, you use pygame.draw. For a circle, you do pygame.draw.circle. You set the surface that you want it to draw on, so like the display surface or another one. The color in 255 RGB, and if you have SRC alpha, you can also have an alpha channel. The center of the surface on the screen. So the screen starts at 00 at the top left and goes down to the width and height you set it to. So then you can set the radius of the circle and also the width. So this is the width of any lines, the line circling the circle. If it's greater than 0, it won't fill the shape and it'll just draw the line around it, the color you set here. You can also draw polygons, which the point list is just a list of tuples with the XY position. Line, just the start pos, end pos. By default, this is 1, so you can set it to be larger if you want. And pygame.draw.rect allows you to put a rect object to fill in an area. So here's just a quick example I made, just two shapes going from different points related to the mouse position. So the rect type. The rect type is simply a rectangle. You can create it by setting a variable to equal pygame.rect, setting the furthest left point and the top point, and then the width and the height. And this will make a rect. So you can do lots of commands on Rect. So you can move it, which will move it, which will return a Rect which has been moved by this position, or moved to, I can't remember. You can clamp it, which will clamp this Rect into this Rect, so if it's outside, or any part of it's outside, it will be immediately moved so that it's fully inside this second one. You can union it, which will return a Rect that encompasses both this Rect and this Rect. You can clip it, which will only show places, which will return a Rect where all the places are encompassed by both the Rects, and collide Rect will return true if this Rect is colliding with this Rect. So with all of these commands, you can do _IP at the end. So rect1.move _IP will instead of returning a Rect, it'll move this Rect it'll just move it in place. And so you can do it with most of these. And so you don't have to have like rect1 equals rect1.move, you can just have rect1.move, which makes stuff easier. So Rects, you can also have all the properties of the Rects, which you can get and set them. It's X, Y, top left, bottom right, top left, bottom left, top right, bottom right, mid top, mid left, mid bottom, mid right, center, center X, center Y, size, width, height, W, and H. Which anything you ever want to change in a Rect, you can change it with these. So here's one example of Rects. So I've got this blue Rect and the purple one. When this Rect tries to get outside of within 30 pixels of the edge, I'm creating a Rect that's the same size as a screen, but 30 pixels from the edge. And so then this one won't quite reach it because it's being clamped. I'm also using collide Rect so that when this Rect is colliding with this one, it goes purple. And so in this example, I've got just two Rects which are being drawn, just the outlines though. And so I'm also filling the screen in the area of where both of these Rects are being clipped to, so then you can get this cool effect where they both are, it becomes blue. So event handling. So you've been watching me doing stuff with Rects and shapes, and you've noticed how I've been using the mouse to control it, which I haven't told you how to do, but now I'll show you and you'll be able to do it. So pygame.event.get returns a list of all the events that have happened since you last called it. So if you leave it a long time without calling this, your program will eventually crash because this has been getting too long. So it will return lots of different types. So each of these is a different thing that can be returned in each item. So pygame.quit gets called when you press the close button, because your program won't actually close automatically when you press the close. You have to get the event of pygame.quit, and then you can call like sys.exit or something. Active event is when the mouse changes from outside the screen to inside, or vice versa. Key down gets when your key is down. Key up, mouse motion is when your mouse moves. It returns, then you can get the item will also have like the position, the relative movement, and any buttons that are down. And mouse button up will return the position and any buttons, mouse button down, and then lots of joystick stuff. And video resize is the event that gets called when you've resized the screen. And so then there's these other ones which I'm not sure what they do. So here's the most amazing piece of code I've ever used for Pygame. So for event in pygame.event.get, if event.type equals pygame.quit sys.exit. This will allow you to close your program by pressing the close button. And so here I've got this program, which it'll just set this rect to have its center at the mouse position. The screen will go grey when the mouse leaves it, and it'll also move the rect when you press any of the buttons. Okay, so pygame.mouse is used to get lots of stuff to do with the mouse. Parts of it are like pygame.event.get, except you don't have to wait for an event to happen to get its states. It's just whenever you call this, it'll give you the states. So you don't have to have any monitoring variables. So pygame.mouse.get pressed will give you the left mouse button state, center button state, and right. Pygame.mouse.get pos will give you the X and Y position. Pygame.mouse.getRel will return you the X and Y movement since that it's moved since the last frame. So if you call this, then you'll be able to move an object twice as fast or half as fast as the mouse. Pygame.mouse.get focused will return whether the mouse is in or out of the screen. Pygame.mouse.setVisible will allow you to set whether you can see the mouse or not, and setPos will allow you to set the position of the mouse. So this is something I made with that. So I've got it so that this ball moves twice as fast as the mouse. When you click, it goes a different color depending on which mouse button you clicked, and when the ball collides with the mouse, it teleports, and when you leave the frame, it goes grey. Okay, so pygame.key is similar to pygame.mouse. The most important thing in this is pygame.key.getPressed, which will return a list of all the states of all the keys. So here's a list of all the keys that Pygame can monitor. I'm not even going to bother trying to read them out, just numbers and symbols and numbers and letters and keys and symbols and numbers and stuff. And so this is another piece of really good code. You can go keys equals pygame.key.getPressed. If keys pygame.kleft, print left. This will print left every frame when your left key is down, which could fill up your command window really quickly. So here's an example that I have. So like pygame.mouse, it also just returns the states, and so you don't need to wait for an event for each of the keys. So you can stop having hundreds of different monitoring if you're doing something like that, which I don't like having those variables to monitor stuff, so I love this. So pygame.time gives you some handling over the frame rate of your things. So pygame.time.wait will wait the amount of time you put in there in milliseconds. So that can slow your program down a bit if it's going way too fast. So pygame.time.clock is a class within this. So you can set a variable to equal pygame.time.clock, and then you can call clock.tick, and then you can set the actual frame rate rather than the time to wait. So this is really good if you want to set the frame rate of your game so that most people who use it either are lagging terribly or they're at the right frame rate. It's usually at the right frame rate. And so get FPS will return the FPS of your current running speed, and I think it uses the average of the last 10 frames. And so this is the key press example without clock.tick and setting the frame rate. So it moves quite quickly and can be a bit hard to follow. And so then I've put a cap on the frame rate in this example, and so it moves a lot smoother. And even if you think it's moving too slow, instead of setting the frame rate higher, you can just set the speed to be higher. So always use a frame rate cap. Okay, so far I've just been using shapes, but Pygame can also do images and all sorts of things. So to load an image, you use pygame.image.load, and then you set the full file name of the image you want to load. Image.convert will convert the image to be the most optimal size for blitting onto the screen. Convert alpha will do the same thing, but it will also maintain an alpha channel. So if your image has like a gradient or something, or just ordinary full alpha, then you call this so that it won't just draw like black or something on top of the rest of your game. So when you use this, you're actually creating a surface. So you can do all the things that you need to do with a surface, or can do with a surface. And so, because it's a surface, you can do like surface.get rect and all sorts of surfacey stuff. So here's just an example I made with some surfaces. Instead of having to draw lots of lines in the background, I've just made a surface and made it the colors. I've also made this arrow thing to show you where your mouse is, and it's got a gradient, which you can see that because I'm using .convert alpha, you can see that it's nice and smooth and it's not completely overfilling the background. Okay, so because your images are a surface, you can get the rect of them, get where you're blitting them to, and then you can make a rect there and then collide it with another rect of another surface or another rect that's in your game. So you can create something like this, where I've got two surfaces being drawn onto the screen. I'm getting their rect, and if their rects are colliding, then I'll move the target to a random place on the screen. And so, yep. In this example, it's always good to note that your surfaces are actually outputting rects. So even if your thing is a circle, you can get closer and closer and closer until it touches the rect. So even though your images don't look like they're touching, their rects are. So you've got to be careful with that. So you can do pygame.sprite is just a simple thing that makes all your rects and your surfaces, it just combines them into one. So this can make your programming a lot neater. So I just got this piece of code off the pygame.org website. So you create a class and you inherit from pygame.sprite.Sprite. Then in init, you just call the pygame.sprite.Sprite.init and have self in there. And so that will make the sprite all work, and you can do stuff with self.image, which is the surface location which the sprite uses to draw with. And then you can do it's a surface, so you can do anything with surfaces like an image or a solid color. You can self.rect is the rect that the sprite uses to collide and stuff, and so that is presumably the same size as the image, so you'll use self.image.get rect to make the rect. And so you can call different commands on sprites. Sprite.kill is useful if you're creating a lot of sprites, so when they're like out of the screen, say, you can just destroy it and it won't lag out your game. Sprite.update will call the update function on your sprite, and sprite.add will add the sprite to a sprite group. And so So it's got the image and the rect, which you can do stuff with. Pygame.sprite.group, it's a sprite group, so you can have a group where this sprite instead of having to assign it to a variable, say var equals sprite class name here, and then create it like that, you can just call the class, and so you do sprite class name and then any arguments that you have. This, if you have called this beforehand, it will give the reference to this group, and then you can do updating and collision detection through the group. And so groups can do group.draw, and then it'll draw everything in this group onto the surface. Group.update will call the update function on all of the objects in this group. Now, if you do this, you've got to make sure every object in the group has an update function and also has the same arguments. So it's good to have like a couple of groups that you've got the static objects and moving objects that have different arguments and stuff. And group.has can tell you if there's some sprites in a certain group. So you can call pygame.sprite.Sprite collide to see if a certain sprite is colliding with a group of sprites. This do-kill will kill the object in the group if the sprite is colliding with it, and so this will return true if the sprite and group collide, and then you can do fancy stuff if they are. So here's an example I made using sprites. I've got these balls that just fall and accelerate downwards. They're created while the mouse is down and get destroyed as soon as they leave the frame. And so I've also got these blocks which the balls will actually bounce on. And so you can create lots of cool things. And so the blocks don't destroy, and if the sprites are on blocks, they won't destroy either. So if you just stand there for a while and just create lots of sprites, eventually your game will start to lag, because sprites do make lag, especially if you're creating one a frame and you have lots and lots of frames. So how much time do I have?
12 minutes.
Okay, so I think I do have enough time to cover sound. So pygame.mixer is the sound module within Pygame. It can handle everything you want to do. So the sound object you can create by calling pygame.mixer.sound and then setting the file name. This will make a sound object, and it'll load this file name to have as that sound that will play. When you call sound.play, this will just play the song for this. It will repeat this many times. If you've got max time, it will stop playing at this time, and fade ms is how much fading you want to happen at the beginning. Sound.stop will just stop the sound from playing whenever. Sound.fadeout will, instead of just plain stopping the sound, it will fade it out over this many milliseconds until it's infinitely quiet, and then it'll just stop playing and you'll be able to start playing again later. Set volume will allow you to set the volume of the sound between 0 and 1, where 1 is the loudest and 0 is off. So I've got this example which I'm using. I've got two different points. Okay, so I've got two different points. One's playing the drum sound and one's playing the notes. And so when I get close to one of them, I make the volume lower until you can hear only one of them, and then I can move over to the other one to get rid of the drums. And so I'm just getting the distance, doing some maths, and making it so that it's quieter closer. Okay, so pygame.mixer.sound basically does most of the stuff that pygame.mixer.music does, but pygame.mixer.music is made for longer files, so instead of just loading it all at once, it streams it, which can be more efficient. So to load it, you don't actually, it doesn't return a variable or an object that you can do stuff with. It's just a reference which happens all within Pygame. So you do pygame.mixer.music.load to load the file name. Music.play will play this file name with the loops and from start seconds within the song. Pygame.mixer.music.rewind rewinds to the beginning. Stop just stops the music. Pause and unpause will do as it says. Fade out. Set volume. Q will add a song that you add to the queue of music to be played. So when the current song is finished, it'll just start playing that one. If you add several songs to the queue, it will just, when you add the next song, it deletes the previous song and adds itself. So you can only ever have one in the queue at the same time. Some last tips and tricks. Only ever update once a frame. If you do, things will not quite be as you wanted. Some objects will move before others and it'll look like they're colliding and they're not, and it'll look like they're not colliding and they are. And only call tick once. If you call it more than once a frame, then it'll mess up the frame rate and it'll slow your game down and it'll mess with the timing. And the last thing that you want to do in every frame is draw and then update. Always, instead of just like drawing one thing up here and then moving things and drawing the next thing and moving things and drawing the next, always draw last so that in case you draw something up here and then you move it, it'll look like they're not colliding and they are, and other things. Any questions? What?
Show us some code.
Okay, some code. So there's that. I've got all the examples here. Keyboard. So I import pygame and sys so I can close it. I initialize it, make the screen. I get pygame.time.clock so that it doesn't run insanely quickly. Then I just create a rect and make it at the top left corner and size 64 by 64. So while true, I get all the key presses, and then if the key is the left key, then move it left by 4 pixels, right by 4 pixels. If it's been pressed up, then I'll move it up and down. Then I clear the screen. I think I've got the drawing wrong, so don't follow this example. I clear the screen so that anything left over from the last frame gets covered over so that you don't get long blur lines. So if I get rid of this, it should... Nope, I think I have another thing. Forgot to save it. So then it keeps the previous frame and doesn't draw over it, so you can still see everything, which doesn't look too neat in a proper game. And then I fill the screen in, the color blue, and where the rect is. So when you pass a rect in, it'll only draw where the rect is. So instead of having to do pygame.draw.rect, you can just do that. I update it, and then do the clock.tick so that it'll set the frame rate, and then if I press close, then close it. Okay, does anyone have any questions?
Hey, great talk, thanks very much. A couple of times you alluded to the fact that if you process too many events or you've got too much background you get all sorts of slowdowns and lags and things like that. Are there any facilities in those event handling to work out how many events you've got in that backlog? So, for example, if you have got a massive backlog of keyboard presses for some reason, you can ignore every third one to sort of optimize ignore a whole bunch of commands in the interest of actually making the display catch up. Do you have any ability to introspect into what events are there other than just walking over everything and ignoring it based upon the fact that you've processed everything?
So if you're just running things normally and the event loop, it doesn't usually get too much. If you call it once a frame, then it won't lag. With sprites and other stuff, I don't think you can like loop through sprites or anything to only do some of them. Just make sure that they can be killed somehow, and everything, just make sure that nothing just stays there unless it's like the background or something.
Sorry, I was thinking more in the lines of, let's say you always want the physics to appear to be real world physics, but because I've got a lot of sprites on the screen, I can't display, the maths of doing all the physics is going to take longer. I'm happy for it to go one frame every 3 seconds as long as the actual place where it is consistent physics. But then I've got to know I have to ignore a bunch of stuff in order to make that happen. So do you have the ability to see how long it's taken for that frame, or how many events have queued up, and then I'm going to ignore all of them just so I know that the frame that I'm going to draw at the end, which is the most recent event, is the one that I'm going to respond to?
So you can use clock.get FPS to get how fast it's running. I don't know if there is, I don't think so, but if you get clock.get FPS, then it will return how long since the last frame, or the FPS. I think clock.tick will return how long since the last time you called that. You can probably get it so that you can get that speed, and then you can probably times all your movement by that. Yeah.
Okay. No, thanks.
So you've put a game up on Google Play. Was that written in Pygame?
What?
You put a game up on Google Play for the Android?
Yeah.
Was that written in Pygame, that game?
So the game I made, I didn't use Pygame for it. I used another language, but I just thought I might tell you all.
Cool.
Tell us what you wrote that in.
I wrote that in processing, which just does it's basically Java, but it makes all the image handling really easy. You can just draw circles by just going circle, which can be a bit annoying at times just because it's too simple, but it's mostly good for all the drawing things.
So is there an opportunity to actually do rotation or anything like that? Because you were very much in a up, down, left, right mode before.
So if you want to rotate an image or a sprite, in Surface there's a command that you can run. I think it's surface.rotate, but that has, the last time I used it, I had to reset the object before turning it again. I'm not sure if that still happens, but yeah. So you can turn it, yeah.
So when you talked about the collision detection and then it was just doing rectangles, is there any way you can do kind of, like if you wanted to collide spheres, circles, can you do that?
Yeah, in Rect, I think you can do, maybe it's something else, but you can do collides, I think it might be sprites that you can do collide circle, and that'll collide two circles, test their distances for you. I don't know if there's a way to collide a rect with a circle, but you can do collide circle for that.
Two connected questions. Did you use Pygame for all of your entries in PyWeek? And if you used other things, could you compare Pygame to what other sets you used?
Yeah, I haven't used any other things. All of these were made with Pygame. Some of the earlier ones, I had no idea what I was doing. I was just copying and pasting code and hoping for the best. But yeah, I've just used Pygame and it's worked good for me so far. So there are other things that you can use, but I haven't looked at them.
Hey, Cody, thanks very much for your presentation. I remember you talking yesterday after Peter's presentation that you'd used Pill in a little gadget, I think, that you'd made. I was wondering if you'd given any thought to integrating Pill into a Pygame for maybe updating graphics or something like that.
So I have used Pill and Pygame together, but mainly just so that I haven't thought of anything to do yet. I've made one thing where it did some image processing, looked at their pixels, and then I used Pygame to see what Pill was actually doing. But I haven't really used it past that.
Thanks.
Yeah, just a quick one. I was wondering when you had the slide about the mouse events there, if there a way to get the scroll wheel input at all?
I don't think so. I don't think there's any way to detect scroll wheel. There's a way to detect the middle button, but that's not really the same.
Thanks for the awesome presentation. How does Pygame go on multiple platforms? Does it look sort of identical, or is there anything to watch out for with that?
I think it works on all platforms. It's for my Pi weeks. I think it worked on most machines, so I don't think there's any platform difficulties there.
That was great, Corey. In appreciation, we are going to give you some coffee, the Norwegian Blue blend from our sponsors. Do what you will with that. And the PyCon AU mug for you. Everyone join me in thanking Corey. And that lets us